Hello, you're watching TelecomTV and our coverage of the Green Network. I'm Guy Daniels and this is our practical guide to energy efficiency for telecommunications providers. And over the course of this programme, we will look at how to first build and then implement an energy efficiency plan that spans data centre and RAN workloads. And joining me on the programme today to outline the steps that can be taken from planning through to hardware and software considerations are Frank Escaros-Buechsel, who is Global Telco Architect with VMware, Raghunathan, Director Commercial OS Infra Software Readiness at the Network and Edge Group Intel, and Valentin Bondzio, who is Customer Sustainability Architect at VMware. Now, I'll be talking with our experts later in the show, but first of all, we have a series of 3 presentations for you. And we're going to start by hearing from Frank Escaros-Buechsel, who will discuss the growing importance of sustainability within the network and the tools available to help telcos. Frank.
Thank you. The first thing to say is that energy efficiency and sustainability is actually a journey which you do start by measuring today, planning ahead, and improving tomorrow to then remeasure and iterate. And today we're going to start by taking a look at which tools we have in the bag and available to you to help you getting started on that journey. In the past, very little differentiation was actually conducted for most use cases within telecommunication providers when it came to workloads. While stability and security have always been on the forefront for those virtual machines, because if it is unavailable, your subscriber service just falls apart, performance has been the third most important measure, really. Very little thought was given to sustainability. But these days, times are changing. The lines between the services that a telecommunications provider, especially in the near edge, is providing versus what would be typically classified as IT-based services is kind of getting blurry. With this and the changing customer expectations for corporate responsibility, there also has to come a shift in mindset, right? Now, performance is not the king of the castle anymore. Sustainability will have to play a role within providing your services. Telco environments today are really distributed across many sites. You have your core sites, which are the hosting sites for all your management services, the service assurance piece, today also AI and machine learning workloads. But the further you move out to the edge, the more subscriber-based services you're offering. In the past, in legacy networks, this used to be 2G and 3G services with vRAN and Cloud RAN being introduced. And today you have O-RAN with CUs and DUs. But there's also a third type of edge, the near edge, which allows you to offer services that are not cell-site services, but other value-add services like augmented reality, smart factories, smart cities to your customers, where you still have a decent amount of density. You're not talking about 10,000s of sites here, more like hundreds to thousands sites, but still it does add up in the overall scheme of things to actually have workloads deployed there. So energy savings there is extremely important. If we start looking at requirements between the far edge and the core, we can see that there is different levels of performance and latency mandated by different use cases. Smart factories and robotics require much stricter latencies than augmented reality or virtual reality game and use cases, for example. So while these services tend to move closer towards the end user and subscribers there is still plenty difference between revenue generating streams for modern communication service providers. This will be important later on when we classify different risk models on the impacts of energy savings. So how do we balance energy efficiency while retaining sufficient performance to run critical user-facing workloads? What hardware and software efficiencies can be utilized to uncover energy-saving opportunities? Vinod and Valentin will deep dive into this for some of the features within a few minutes. As most of the energy consumption today, though, roughly 70 to 80% is spent in the radio access network, there is an important focus on optimization to minimize energy consumption without compromising coverage, connectivity, and performance. Examples of technology which can be utilized here are the RAN intelligent controller, where RApps and XApps can optimize beamforming or massive MIMO use cases, use heuristics and AI and machine learning to shut down specific radio antennas during lower activity times while still retaining quality of experience metrics for subscribers. Another avenue is right sizing, which can have a substantial impact on the core, but also supporting data centers, which every single telco uses to run the massive amounts of IT services to provide services to their subscribers as well. This becomes extremely important, as well as some of the solutions to previous problems like AI and machine learnings themselves do have much higher resource requirements. Having identified some measures and methods for more energy efficient operations, we should also identify some of the low-hanging fruit and risk factors where easy changes are possible and where subscriber impact is much more risky. Due to the nature of the traffic with high throughput and low latency requirements, which by nature carry a higher risk for utilizing energy efficient features, as you simply can't beat physics and radio standards. They don't wait for efficiency induced scheduling delays after all. But within most components, especially as you move more towards the signaling and control plane traffic, but also those near-edge functionality that we talked about earlier, you do get much more lenient latency requirements, which helps a lot in driving those efficiency measures without posing an immediate risk to subscriber impact. However, this maybe should just be timed in terms of you introduce efficiency measures during low peak numbers of subscribers, for example, in the middle of the night, and then you reintroduce the high performance functionality back during your peak hours during the day. The easiest environments to really start looking at, though, is all your supporting services. OSS and BSS systems supporting applications like your CRM and CMS systems, but also don't forget your test and development environments. Typically, they don't need to run 24/7, 365 days a year. They come in test cycles. Do they really need to be powered on all the time? Do they really need to have the highest performance setting all the time, even if they are powered on? Let's take some areas for improvement on energy efficiency to explore for each of the risk areas next. So, within the high risk area, most of you would be looking at choosing the right hardware for the task at hand, pick the correct CPU model, the correct NIC model, and offloading cards for the highest performance factor with the lowest power draw. Again, Vinod will cover certain of these features in just a few minutes. In the medium risk area, modern hypervisor technology offers many benefits to increase efficiencies. So start by exploring and utilizing those features and functionalities after you have tested them. And in the low risk areas, overcommitment and host power management can offer substantial efficiency improvements. Valentin is going to cover especially the power management piece in just a tiny bit. One more thing I want you to take a look at really is closed loop remediation and closed loop automation. Depending on measured key performance indicators for either your UEs or from an application perspective, you can start by inducing certain automated scripts and remediation actions. And there is a variety of different approaches possible. It doesn't need to be a singular product in the market today. It can just be as simple as utilizing a message bus and kicking off a script to get things started, or even easier by starting with simply a scheduled task to shut down and power on hosts over a night cycle. An example of how AC cooling can be controlled is linked in this slide here. So how would this look like in more detail? Well, first of all, you need to start by measuring things, and not only at a single level, but at multiple levels. So you collect the metrics on your bare metal infrastructure, so the actual servers. You collect metrics on the Kubernetes layer if you're running CNFs, for example, and you collect metrics on your Vim layer. You aggregate these and feed in alarms as well into a service assurance product, which then can trigger remediation actions into the actual automation engine, be that an orchestrator or any other CI/CD pipeline, for example, that allows you to make changes to your environment to then act upon these changes. So this could be, for example, scale in your workload or scale out your workload to not always be sized towards peak times, but rather to dynamically resize in terms of actual needs while still meeting quality of experience KPIs. And again, this can happen on several different layers, like your CNF or your Kubernetes infrastructure, but this could also be changes in the settings on your passive elements. So with having talked about some of the measures and functionality that you can use to get your journey started on the energy efficiency path for a telecommunication provider, I'd like to hand this over to Vinod now to talk more about the actual Intel functionality that will help you on that journey as well.
Thank you, Frank. Before I get into the details of the CPU and the other features that Intel brings in, I just want to touch a couple of minutes on the overall Intel vision for sustainability. Intel sustainability is end-to-end. We want to reduce Intel's footprints across the entire manufacturing supply chain and then build that into our products, platforms, software, and services. And this requires working up and down the ecosystem, right from our suppliers all the way down to our partners and customers. And some of the commitments that we have made today, 93% of the electricity that we use to make our products, this is all renewable. We have made commitments to get to net zero emissions, both Scope 1 and Scope 2 by 2040. And we want to get net positive with water consumption. As you know, much of our manufacturing uses tons of water. And today, in 2022, we are already net positive water, both in India and the US. We want to do that globally by 2030. So in short, we want to be the leader in driving sustainability efforts across the semiconductor manufacturing industry and beyond. So with that, I'll get into the details of the processor features. So recently we introduced our 4th Gen Xeon Scalable processor. It's our most sustainable data center processor yet. With this processor, we are able to get 14x performance per watt boost on AI inference workload. We also have a ton of built-in accelerators like QAT, data streaming accelerator, all of this resulting in 2.9x performance improvement in performance per watt. And even at a base level, we are able to get 20% CPU power savings at 5% or less than 5% performance impact when we use the optimized power profile. And what just as I mentioned in my previous slides, these are manufactured at our state-of-art silicon fabrication and assembly facilities, where we have state-of-art water reclamation and renewable electricity. So all in all, incredibly sustainable processor. Now, how does this matter to the end customer, the communication service provider? With these features, we are able to, with the built-in accelerators, across the network location, all the way from access to the core data center, we're able to drive end-to-end energy efficiency with power optimized performance. We introduce our 4th Gen Xeon Scalable with vRAN Boost, where we're able to offload the L1 processing for vRAN onto a onboard accelerator within the CPU package itself, CPU itself, and that is able to result, we are able to get incredible power and performance. The other piece, which Frank mentioned early on, which is all about detecting, monitoring, and iterating, that requires a ton of telemetry. And then that feedback loop that Frank talked about for power management, the closed loop feedback, all of that telemetry and power management features, we have it built in our processors. And then finally, we do have to work with partners like VMware to leverage those power management features to get that closed loop feedback across to provide the end-to-end sustainability. Diving a little bit deeper into power and performance capabilities, as you can see, we have all of these different power and performance capabilities um, in our processors. We have turbo boost, we have energy efficient turbo boost, which are all able to modify our processor frequencies depending on the workload requirements. We have the processor P states and C states, which the workloads can, depending on how the workload needs, we can change either the frequency or even the power state itself based on the processing needs of that particular workload, which I will share a couple slides down the line on how we leverage that. We also have wait instructions starting from our 3rd generation, 4th generation Xeon Scalable processors, which allow us to leverage and manage the exit latencies from these different power states, which then allows to fine-tune the performance and power consumption. So based on the use case, based on the location, based on the needs of the workload, we can fine-tune what the power consumption is. So we have tons of opportunities here. In fact, VMware, starting from vSphere 7.0, has some power management host capabilities which leverages the C states and P states. But these are static C states and P state power management, where you can set or leverage 3 different profiles: the performance profile, the balance profile, as well as the low power profile. And I'm sure Valentin will touch on this more in his presentation following me. On the core side, we have driven specific solutions, especially considering that we have DPDK-based workloads which keep pulling the NIC for packets, which may make the core look busy. So we have introduced something called Intel Infrastructure Power Manager, where we are able to demonstrate up to 30% power efficiency based on the DPDK workload. We're now trying to extend that to user plane and control plane as well. Today it uses the C states. In the future, we want to leverage the P states based on the workload needs. Of course, it would be a miss if I don't touch on the improvement that we have made in the vRAN market with our FlexRAN baseband unit scheduler enhancements, where we're able to leverage different C states and P states when the suspend API and the resume API works. Previously, with the optimized scheduler, the blue and the yellow blocks used to be more scattered and more closer together, and we had to use only the C1 state, which because of the exit latency requirements. But optimizing the whole processing pipeline, we're able to create these bigger blocks where we can send the processor down into a C6 state, which results in higher power savings. So what does this give for us? Incredible possibilities. With just using C1, we're able to do only 40 to 45 watts on a 160 watt power window here. But managing those workloads together, improving those schedulers, we're able to eke out another 15 to 20 watts of core consolidation and sending cores to C6 state. It's always better to keep fewer cores at higher utilization than multiple cores active at lower utilization. And that's what we strive to do. And 62 watts of power savings on 160 with no power savings, that's significant for any communication service provider. And what more, Frank said 75% of the energy consumption happens in the WAN. So this is going to be a very viable solution for all our communication service providers. And we look forward to working with VMware in this year to bring this to the VMware Telco Cloud environment. And I'm sure Valentin is going to touch more on all of this in his session. Over to you, Valentin.
Thank you very much, Vinod. My name is Valentin, and as we've mentioned before, I'm a customer sustainability architect, but I'm also a little bit into performance, as you can see by my extreme performance shirt. From the 14 years I worked at VMware, 10 of those were spent on performance, and telco and NFV enablement was at least 4 of those as well. So performance is my main focus, and sustainability is something we want to enable on top of that, not next to it or an alternative of. So when we talk about host power management, and some of what Frank has said before, this is applicable to some of the low-risk environments, but at the global host power management level, what is the impact? We want none, or the least possible impact, while also increasing power efficiency to some extent. To what extent, that depends on the application, the type, and possibly the time of day. When we talk about control, we do want to retain 100% control. We always want to be able to run at maximum performance without any power efficiencies whenever it becomes necessary, whether that is just a specific situation, whether that is for specific workloads or at specific times of day. We always need to be able to retain 100% control. No host reboots, no long maintenance windows. It has to be controllable using API, UI, or automatic orchestration, like Frank mentioned before, in seconds. But we also want control about power efficiencies. We want these knobs so we can tune them applicable for the underlying workload and possible time of day. Now, when we're looking at host power management, there are things you can do in the BIOS which controls a variety of technologies of the hardware vendor, of the CPU vendor, Intel, all of the features Vinod talked about earlier. Now, we also have policies at the ESXi level, and these policies control, together with the technologies, the outcome. I'm oversimplifying here by saying there's maximum performance and maximum power efficiency. Sometimes they're the same in certain workloads, because sometimes you really can have your cake and eat it too. In other cases, they're diametrically opposed. But if you have maximum performance configured, which is what we recommend in most of our best practices, no matter what you do at the ESXi level, your outcome will be maximum performance or low latency, low jitter, whatever those defaults are. We don't override these, we demark at that level. Now, I'm going to skip some of the other ones. Spoiler alert, they're not optimal. So what we're proposing is what we call a custom no-risk host power management policy, because we want you to be able to retain that maximum performance at ESXi level control. But we also want to give you the opportunity, the possibility to use different settings, to use different policies, to use different methods of control to retain flexibility within that maximum performance, but maybe not maximum power efficiency level. Right? Giving you a little bit of leeway, because this is an iterative process. You want to tippy-toe towards more efficiency. You don't want the pendulum to overswing. You don't want to go all maximum power efficiency, realize you overcorrected and you impact your workload. That's what we want to avoid at all possible time. So we call this no-risk host power management. There is a possibility, and this is at the global host level here. When we talk about host power management, what it does, it kind of works the same. No matter whether you're looking at ESI, ESXi, or other operating systems, bare metal, you do something in the BIOS, that you configure, that the hardware provides, and you can override or control some of that using OS settings. Now, in the past, in ESXi, in the long past gone by times, this power management policy affects the whole host and every VM just based on utilization. When we introduced 7.0 or when we introduced latency sensitivity VMs in 5.5, you cutting out cores for a specific VM. With that cut out, you have full control. In 7.0 update 2, we included in that control that we no longer use p-states or frequency scaling for these VMs. So now, even if you're running a host power management policy, your most latency sensitive VMs are excluded and removed from that. They have full control. How does that look like? These latency sensitive machines have something that we call strict exclusive affinity. So the vCPUs are bound to a thread of the underlying cores. And to give you that full determinism, we're not using hyperthreading. We're idling the sibling so that you have full control. But that also means both threads are exclusively available to that VM and one of them isn't doing anything. What we also introduced with 7.0 Update 2 is the ability to only use that exclusive affinity for a subset of vCPUs. For example, wherever you run your DPDK cores. So you retain the ability to overcommit the capacity that otherwise would have been consumed, even though the parts of the VM wouldn't necessarily need that. So you can cut down on the CPUs you have to grant to a specific workload. In 8.0 GA, we introduced latency sensitivity and hyperthreading. One of the comments of some of the providers was, hey, we want to use hyperthreading because it gives us capacity. We optimize for it. And they're perfectly right. Now, what we introduced was the ability to present the exact underlying hardware topology through to the guest. So the VM is now aware where it's running, the guest knows that it has hyperthreading, and we sequentially give it the vCPUs to the underlying threads. So if you had a workload that required a certain number of vCPUs, but didn't care about threads or cores, you can now give it half the amount. And again, as I said before, some vendors optimize for HT to give you even more than the prognosed capacity improvement of SMT or HT. Now, with that being said, where do we go from here? This latency sensitive VM has been cut out. It has its own capabilities. It no longer listens to the host topology, to the host power management. And Frank talked about this. Host power management at the global level is good for low risk, but once we talk about starting high risk, like Vinod said, for example, the DUs, the CUs, right, the RAN, what do we do there? Well, one of the answers Vinod already talked about. We idle. And C1 or halt has always been possible. So the C1 state that Vinod talked about, you can do that right now. You have a latency sensitive VM. It is being passed through to the guest and the guest can use it. Now, in 8.0 Update 2, what we introduced was a feature that was only shortly mentioned, and that is the improvements in Sapphire Rapids to allow an application itself to idle. Because before that, an application had to idle, it had to yield, it had to give control to an idle thread in the kernel, but to save that context switch and to make it an even more latency sensitive idle mechanism, we introduced this and enabled this in 8.0 Update 2. And from here on, with the technologies I talked about, where we were, where we are today, I want you to extrapolate to the future about all the things we're doing with Intel and how technologies will evolve in this virtual telco world. And with that, I'm at the end of my presentation, and I can only say thank you so much for listening, and Guy, back to you.
Thank you, Valentin. Now that we've watched all three presentations, it's time to have a chat with our guests. Hello again, everyone. Great presentations, really interesting. And as Frank said at the start there, it's very much a journey we are on. Now, I do have a couple of questions for you. And first of all, I'd like to ask you, what do you think service providers should do today, right now, to start the journey to a more sustainable future? And Valentin, if I could start by getting your views first, perhaps.
If I could summarize it, it's benchmark, measure, and categorize, and of course test. So there are many different opportunities that you can utilize today, but it's not going to be something that is happening over the course of a day. You need to be aware of your workloads, as we have discussed in these previous conversations, and you need to be able to create a baseline. Some of these discussions that we had
require you to incorporate knowledge of the technologies that we've talked about. There's going to be some operational change. There's going to be some FUD. There's going to be some discussions about whether it's increasing risk. And for that, the answer to these kind of, I want to say, the answer to that fear is usually best done with the knowledge of the underlying technologies, part of which we have discussed here. And if that is done, then I think there's nothing in the way to start on increasing power efficiency, starting at the low-risk workloads and working our way towards the high-risk workloads that Frank outlined.
Thanks, Valentin. And Vinod, do you agree that this is perhaps an iterative process that can be phased in, perhaps?
I completely agree with Valentin on what he said, right? I think to an extent, service providers are extremely conservative. They want the technology to be incredibly mature before they actually implement. But over the last couple of years, Intel with VMware and other players in the ecosystem, through a series of demonstrations, we have shown the art of possible, what can be done, how much power savings are possible. I think service providers now need to take the gauntlet and actually move towards doing those proof of concepts in their real network to start realizing, as well as giving us feedback on what more we can do to improve these technologies as we go into the future. As Valentin said, there's going to be some FUD, some change management, which we need to manage carefully. But I think we cannot keep waiting for everything to come together to start realizing these savings. We need to get started now.
Yeah, there's always fear, uncertainty, and doubt. But as you both say, time now is to actually start and make commercial implementations. But I'd like to ask, is what you have just presented relevant to today's containerized environment? Frank?
Yes, a lot of what we talked about is actually very relevant for containerized environments, because most of the time the containers do run on Kubernetes nodes, and especially within a VMware environment, these would be running as virtual machines. So all the benefits that we talked about are actually applicable to both VNFs as well as CNFs.
And, can I ask, Valentin, is this scalable? Is this a dynamic process for telcos, or do they have to go all in from the start?
No, this is certainly something where you want to start in iterations, right? So you don't want to overswing that pendulum, right, and go from one extreme to the other. You don't want to go all power efficiency. You want to tippy-toe your way towards more efficiency with small iterative steps that are safe, right? So we're talking about making incremental improvements in certain parts of the ecosystem, making sure you're safe on the performance and throughput, and moving on to the next one. This is not something you want to just dive in head first and basically just wing it, all right? It definitely is something where you want to start in some parts and make small iterative processes. And especially in some parts of the telco, we have seen that depending on where you start, some of the power efficiency gains at the beginning might be fairly small. It might be in the single-digit percentages. But at scale, it's still very, very significant if you're talking about energy and carbon that's involved in those single-digit percentages. So yes, or no, I should probably say, this is something that you should start small in the beginning and then scale it out very, very meticulously.
Great, thanks. And Vinod, do you concur with the small steps or phased approach, perhaps?
Absolutely, completely concur with Valentin. It's going to be a journey rather than a switch here, right? However, yeah, there are already elements which are easily applicable for a cloud-native network, as Frank mentioned earlier. With Intel's FlexRAN, we have already demonstrated that. But then there's also more work as a technology community we need to do with new architectures coming in. We'll have the IPUs or the DPUs that people speak about, which can manage the network better. So overall, it's going to be a journey. And I think Valentin summarized it best. We cannot just dive in head first. We need to be aware and cognizant of the journey of the efforts that we need to put in to start realizing. And at scale, even baby steps translate into large savings at the end of the day.
Yeah, and there's one other question I'd like to put to you, Vinod. We see a lot of interest and demand at the moment for AI and ML. How does this demand impact the work we're doing now?
It's a double-edged sword, right? AI and ML, obviously, especially with this whole movement towards Gen AI, they're increasing the network requirements. There's going to be more power that's going to be consumed across the network. There's GPUs going to be all over. There's other accelerators. However, the other side is this technology can very well be used to manage the network a lot better. We're going to be using these technologies to identify areas where there can be savings, and overall leveraging the learnings from the larger technology. The telcos can actually figure out where they can save, how they can better manage the network. And I think that's where the entire movement is going to go towards, right? We're going to have better OSS, better BSS, which are augmented by AI and ML. And then we're going to have better service and management orchestration, right? Service management orchestration that will help us leverage these technologies to manage. So it's not just I'm going to bring in these new technologies and it's going to consume more power. I'm going to use these technologies also to manage power better overall in my network.
Well, we must leave it there. Thank you all so much for taking part in the program today. And if you would like any more information on anything you've seen or heard in the program today from any of our presentations, then please do get in touch, or you can follow the links below this video for additional resources. For now though, thanks for watching and goodbye.